Hello, everyone.
Hello.
Hey.
Hello.
Hi, hello. Hi.
Some familiar faces here. I like to see it. Okay. Let me just get my activities open. And I'll just give a couple moments for people to join. And then we'll get started. Okay. I'll get going with a bit of an intro. So this is our extended edition Python Intro to Python sessions. So we've had, my understanding is that the invite for this went out to anyone who attended any one of the first four sessions. With the idea that these will be a touch more advanced than the previous ones. Not really, really advanced. We're not kind of going to start building the latest machine learning technology or anything, but we're going to start to solve some problems. And you can actually, I think, make this one as advanced as you like if you want to make it more complex. These ones will be focused more on problem solving. So we'll be using the fundamentals of Python syntax as covered in the previous sessions to solve some Codewars problems. And we're going to start off this week at the lowest difficulty that Codewars has, which is the 8. And then next week we'll be on the 7, so potentially a 6 as well. If in this session you feel like the 8s are too easy for you and you fancy something more challenging, you can go into Codewars and find a challenge that is more suited to your particular interests. Those of you, some of you may not have used Codewars before, so I'm anticipating that I may need to do a little bit of an intro, which I'm going to do now, just so that you know what it's like. And in fact, before I do that, I'll talk through kind of the rough structure of the session. So what I'll ask you to do is I'm going to give you 4 Codewars exercises. You can pick other ones if you want. If you want to find some others, that's fine. But I'm going to give you 4 to start with. Then I'll send you away for 15 minutes. And I'm going to try to find a way to pair up the people who would like to be paired up and would like to do them with another person. But you don't have to if you don't want to. So you'll head off for 15 minutes to work through those. Either you don't need to get through all of them. You can just sort of pick the first one and then try it out. We'll see how many you get through, and then we'll come back. I'll work through a couple of them, and then I'll send you away again to have another go at the exercises, and then we'll come back again and finish off with a kind of run through of the exercises. And if anyone would like me to talk through anything that they found that wasn't on the list, then you're very welcome to propose it in the final session. I'm going to show you Codewars now because its interface can take a little bit of getting used to, and I'm going to put the link into the chat. You don't get started with it yet, but you may need to. In fact, I won't put the link in the chat yet. I'll just show you what I'm looking at. So, for those who've just joined us, so we're going to be doing some programming exercise today, focusing on problem solving and taking a kind of new a new exercise, let's say one that's described to us, and trying to work out what we need to do to actually solve the problem when it's not specified in programming terms. So starting to broaden out the skills that we've looked at so far into more of a problem-solving approach. When you load up Codewars, when you sign up, and you'll need to sign up as part of this, it will take you through a bit of an introduction to the interface, which you can just sort of work through and see how it works, but you'll end up at a page roughly like this. And there are two ways you can find a new challenge to work on, if you do want to find a new challenge to work on, which is you can pick the language you want to study here, and you can pick either fundamentals or rank up, and this gives you different kinds of challenge. And the challenges rank from 8, I don't know how to pronounce, I should learn how to pronounce at some point, 8Q, which is the easiest, to 1Q, which is the hardest. If any of you do a 1Q in this session, you probably shouldn't be here because they are very challenging. I think I've never done one, but mostly because they take a long time to do. So today we're focused on the 8Q ones. So that's one way you can get to them. Another one is to go over to hover over this practice symbol here, and you go in here, and it gives you a little filter which you can put a language in this case Python, if I can find it. And then you can select a difficulty here so we can select 8. And then eventually it will show you a big list of different exercises you can do. Just probably, I wouldn't say it's infinite because it's not, but it's very large. So you're not going to end up running out, which is quite handy. So if you want to find them, that's it. But today I'm going to actually show you one, or I'm going to send you some. So I'm going to open up one now. And this is the first one that I'll give you. And when you open up, you'll get to this page. And what you need to do is click this blue train button here, which will take you into the coding interface. And on the left, there are some instructions which you can work through. So this says a bunch of stuff about the exercise it is. And you want to make sure Python's selected here. And then in here goes your code to solve the exercise. Down here are some tests. So we looked a little bit at this last week, but it's a bit of a reminder. Down here are some tests. To run the test, you click the test button once you're code, because I haven't written anything, so it doesn't do anything yet. And then when I'm done, I think all my tests pass and I'm good to go. I click the attempt. And then if the tests pass, the sort of bigger set of tests pass, then I'll be able to submit it. And that would be my solution was correct. So if you kind of get stuck with it, there's a little button in Zoom I think you can press to get help. So you recommend you press that if you get stuck with it. So as a recap, now I'm pretty sure everyone's here. Today, problem solving using Python rather than just the syntax. You probably need to do some Googling, probably need to think carefully about the problem. The structure will be, I will send you off with 4 links, and I'll put these in the chat shortly. And your task is to work through these Codewars challenges in the links from top to bottom. And if you do feel like these are too easy for you, you can find your own, that's okay as well. And then after about 15 minutes of that, I'll invite everyone back into the main room where I'll solve 2 of them on the call and talk through a solution. So you can see how I would solve them and have me talk through it. And of course, you'll be able to ask questions as well. After that, presuming we've got time, I'll send you away for another 15 minutes to keep working through the exercises, potentially with a bit of improvement based on what you've learned. And then we'll come back and close out the session with a review of the other 2 exercises, or anything else that you would like to propose, any other Codewars exercise you'd like to propose me go through, as long as that they are the 8 or potentially 7 Q1s. Please don't give me a 1 Q1 because I won't be able to do it on the call today, or possibly at all. Any questions on what we're going to do with the session? Okay, looks like we're in a good place. In which case,
not in good place.
Go ahead, Grace. Hey, Grace, how you doing?
Sorry. Can you go over what we need to do because I joined late? Please, yeah.
Sure.
Yeah. Thank
So I'm
you.
going to put 4 links in. Well, I'm going to put them in now. And your task is to click the first one. So you remember we went through Codewars at the end of the last session. To go through the first one, and then the second one, and the third one, and the fourth one, and to complete the coding exercise in that. You'll do that for about 15 minutes, and then we'll come back here. I'll talk through 2 of them, and then I'll send you away to do some more, and then we'll come back here and we'll talk through 2 of them. So if you get stuck at any point, please do. There's a little button you can click in the Zoom to get my attention when you're in the breakout room. So I'll notice that and try to help you if I can. But that's what we're going to do. I think
Again, Kay, I'm going to post a problem that I got the answer right, but it's still giving me error. I'm going to post it in the chat to you.
Sure, yeah, please do.
Yeah.
Please do. Yeah.
Thank you.
Okay, and I'm going to put you in breakout rooms. So there are 27 of you. Well, there need to be 26. Great. And I think have a go at these individually now. And then the second one, we might have a go at pairing up depending on how you find it. So let's try that. And have fun with it. Oh, and also copy paste out the links to the Codewars katas before I just take a moment now, put them back in again. Copy paste out the links so that you can see them when you're in the breakout room. And I'll rotate around. So I'm going to open them now, and I will swing around pretty shortly. See you in a moment.
Okay, it's not giving me access to copy it to you. It's not giving me access to copy the question to you.
Oh, that's a shame, Grace. Perhaps you could email it to me.
Okay, I will do that.
Please do. Hi, everyone. Hello, hello, I'm back. Or rather, I'm back in your speakers anyway. I realized I had the setting on to just immediately close the breakout rooms the moment that I pressed the button, so you didn't get any warning, but hopefully that's all right. So hopefully so if you still only kind of spend a bit of that time getting set up and kind of getting used to the interface and working on the first one, that's totally fine. Don't worry about it. I'm going to talk you through now the first two. And if you didn't get through them all, that's okay. And then I'll send you away to do two more. And I think that the latter two, or the remainder, I'll pair you up. So I'll talk about that after this walkthrough. I'm going to share my screen now. And I'll keep the chat open. So if you have any questions as to what I'm doing throughout, please do just drop the questions in there. And once I've done a version of it, if you got a sort of solution that didn't seem to work but was close, you've done something but you weren't quite sure what was wrong with it, you can put that in the chat. I'll tell you when, and we can try it out and spot where the errors might have been. So, pillars. This is a classic programming problem in the sense that it seems to have, it's all in kind of plain English, or at least, it's in English anyway. And you've got to work out how do I produce an algorithm to solve this particular problem. And I'll read it out to you. So there are pillars near the road. The distance between the pillars is the same, and the width of the pillars is the same. Your function accepts three arguments: the number of pillars, and this means that the number of pillars is greater than or equal to 1. So it'll be at minimum 1 number of pillars. The distance between the pillars, which will be between 10 and 30 meters, and the width of the pillar, that's going to be between 10 and 50 centimeters. And our task is to calculate the distance between the first and last pillar in centimeters without the width of the first and last pillar. So it's kind of a bit of a logic puzzle, really. And our task is to put this into code. Now, we've got a sample piece of code here, which defines, that's the def, it defines the function called pillars. It takes three arguments. That's the number of pillars, which is here, the dist being the distance, and the width being the width. And down here, we can see there are a number of tests where the pillars function gets called with different values. So it will execute with different values each time. And our job is to calculate the particular number that results from this calculation. So with these sorts of problems, maybe you can do it in your head. I always like to diagram them because then I don't make any sort of mistakes. Okay, so let's do a bit of a diagram. Let's say we've got, what's the first one? Pillars, all right, let's ignore this one. Let's go 2, 20, and 25. So number of pillars is 2. And you can do this on paper as well, obviously. Number of pillars is 2. Distance is, what's that? 20. And that's in meters. And then the width of the pillars is 25 centimeters. Make this a little bigger. So these are our parameters. And if we were to diagram this out, let's say we've got 2 pillars. I want round pillars, I want some square pillars. 2 pillars like this, they're going to be 20 meters apart. And the width is going to be 25 centimeters. So each one is going to be 25 centimeters. And those arrowheads are a little big, so we draw them out. Okay, well, that's kind of weird. So they're both 25 centimeters. And so in theory, if I've understood this problem correctly, the output of this is going to be the distance between the first and the last pillar in centimeters. Well, that's going to be 20 meters in centimeters. And I happen to know from my school days that a meter contains 100 centimeters. So let me write that down. Is that right? That is right, isn't it? I'm not misremembering that. Okay, so it's going to be 20. Output's going to be 20 times 100, which is 20 times 100, 2,000. I should know that without having to calculate it. And is that the right answer? Yes, it is. Okay. So we've got that working. I got someone who said that they missed out something I said. If that also happened to you, or if you want to let me know what you missed, I can repeat it. Okay. So the answer here is 2,000. So I guess that's a simple case, and we could probably put this into an algorithm of some kind, which would be the distance times 100. For this case, because there's a few things we don't have to think about, the distance times 100 gets us the first answer. So we can now sort of, one of the things you'll notice me do when I'm trying to solve programming problems is I try not to solve the whole problem at once. I try to just focus on a particular example or a particular piece of it rather than trying to handle it all at once. You could probably do this all at once. I mean, you certainly could do this all at once. It's a bit of a programmer's habit, and probably a bit of a quirk of my way of solving problems, that I try to just solve one piece carefully first, and then gradually move to more complex problems. So in this case, this times 100, I need to return it. So one of the things you need to do here is return the result from the function. Otherwise, you're just calculating it and not actually sending it back to the caller. So this one will pass this one, but I'm guessing it won't pass this one. So let's find out what it does. That's right. So now that I've got this example working, in this particular case where we've only got two pillars, then, well, that's fine as it is, but we probably need to look at another example, which, let's take this one. We've got one pillar, which is, well, one pillar isn't at any distance from any pillars, and the width is 10 centimeters, but the distance between the first and the last pillar in centimeters, if there's only one pillar, well, that's going to be 0. So I don't really need to diagram that. That's sort of trivial. So I guess I can say if num_pil is equal to 0, then return 0. And then I can run my tests again, or rather 1, sorry. If there's only one pillar, running my test there helped me catch my own mistakes, which is handy because I do make plenty of mistakes. Okay, so we've got 2 cases passed now. And to talk through the syntax a little bit, if you're still getting used to this. So we've got this function defined here, everything indented after the function that's indented at least as far as this is part of the function. It's code that runs when this function gets executed. And then I've got this if here, which says, if this conditional expression, which is let's compare num_pil, which in this case is the number of pillars, with 1, if the number of pillars and 1 are the same, then execute this block that comes after this, after the colon. And then everything indented after that gets run. At this point, I return inside the if number of pillars is equal to 1, I return the result 0. Otherwise, so I could actually phrase this like this, otherwise return the distance times 100 because the distance is in meters and we want the result in centimeters. And that works okay for a 2-pillar case. Now, you may be, probably the thing we haven't spoken about is how on earth can this work? Because there's no else there. Well, the reason it works is because a return always ends the function that it's in. So if we ever hit a return in the course of executing a function, even if it's inside an if, the function is done. It's returned to where it came from, and it doesn't execute any more code. So that's why this one. I'm actually going to put this else in here because I think it makes it a little bit clearer for you to see. Just so you know, it is not totally necessary. Okay, and this one we've already spoken through. Now let's look at the third example. The third example is even more kind of sophisticated. We've got 11 pillars. They are 15 meters apart, and the width of the pillar is 30 centimeters. So I'm going to go and diagram this out now, I think. 11, 15, and 30. (11, 15, and 30). And the answer is the distance between the first and last pillar in centimeters. So if I now want to create some pillars here, I have to create 11, which is an odd number. Okay, 4, 8, 12, minus 1, 11. That's 11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Great. Let me line those up. And they're all 15 meters apart. So I want to kind of space them out a little bit. They're all 15 meters apart. So let me indicate that in here. Oh, such large arrowheads. Let me open that up. So 15 meters apart, and let me distribute those out a little more somehow. Well, that's just annoying, isn't it? Anyway, just imagine these are all a similar distance apart. See, imagine. You get the idea. And then they are 30 centimeters in width. So 30 centimeters in width, and we need to ignore the first and the last pillar. So what we're really taking is 15 plus 30 centimeters, plus 15, 30 centimeters, plus 15, 30 centimeters. So we're taking the 15s for every gap between a pillar, and 30 for every pillar except for the first and last one. Apologies if you can hear those children shouting. I'm sure they're having a good time. So for 11 pillars, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 gaps. So I guess the number of gaps is the number of pillars minus 1, which in this case is 10. And then the number of, let's call them inner pillars, is the number of pillars minus 2, because we're taking off the first and the last. And then if we can calculate this, we can get the distance is equal to the gaps times the gap between them, which is 15, times 100, because it's in meters rather than centimeters. So we need to convert it to centimeters, plus, I'm just going to put these in brackets here, even though it's a little necessary, plus, got some helpers in the chat, plus the inner pillars times 30 centimeters. Yes, and that's exactly what the person in the chat said. Well done. And then we can call this the width, and we can call this the distance, and we've got a formula which works, I think. Let's try it out. So we've got here, let's use this formula out. We've got distance equals the gaps, which is the number of pillars minus 1, that's 10 times 15 times 100, which is 1500, plus the inner pillars, which is the number of pillars minus 2, which is 9, times 30 centimeters, which gets us 15000 plus 9 times 30. Anyone? Anyone do 9 times 30? 27. Is that true? That's probably right. 27, pretty close. Sorry,
270.
270. Okay. Yeah, that makes sense. 270, which gets us 15270, which is the right answer. So let me put this formula in here, which I think should work for all of them now, so I can put it here. So return. Let's say gaps is num pill minus 1. Inner pillars is num pill minus 2. And then we return the gaps times the distance times 100 plus the inner pillars times the width. And in theory, we get this working, apart from I've made a mistake somewhere. Distance, dist. Okay, and do I need the special case anymore? I think I shouldn't need it. Ah, I do need the special case. That's interesting. I guess because if this is 1, then the number of pillars is going to be, the number of gaps will be, yeah, so that won't quite work. But it works with 2. And then let's see if there are any other cases which blow up our logic. No, seems to work fine. And I think I'm going to rename these as well, make them a bit clearer. Open that up and pillar width. Put that there as well. Great. Okay. And now we've got a solution, and I can refactor it to a slightly shorter version there as well, because this return finishes the function early. And the thing that of course, if I do say so myself, the thing that I like about this function is that because I've gone through and thought somewhat carefully about the logic behind the problem, it's some of the logic of how you would explain the problem to a person is in here, which is this idea of gaps and this idea of inner pillars. So it makes it a little easier to read and therefore change it in future, because it communicates the logic of what it's really trying to do. Does anyone have any questions about either the process I've just been through or about this solution or about anything about why their solution didn't work or anything like that, feel free to drop them in the chat or just say them out loud if you like.
Hey, are you going to send the solution to us?
Yeah.
Okay, because it's good to have it and practice too. Thank you. I'm just getting used to the interface.
Okay, let me submit that. So I'm going to submit it, which means I can now link you to it. There we go. Let me link that. So I'm putting this in the chat now so you can see it. I'll put it, I'll send it in the email as well after this. And just a note also, when you look at Codewars solutions, they often have a habit of being a little obscure, a little hard to understand. That is not, while it's cool to have slightly weird solutions or solutions that are very short, it's kind of a cool thing. Just bear in mind that you wouldn't see an industry, like if somebody submitted code like this as part of a software engineering team, it would be very nicely pointed out that it was quite hard to understand what exactly was going on here. So in industry, the thing you go for with code is for it to communicate clearly what the logic of the code is so that somebody else can change it and work on it in future. And because it's, Codewars is a slightly different community, you tend to see solutions that are a little more obscure, but don't let that worry you if yours doesn't look as kind of short as theirs does. Okay, got a thing in the chat. Yeah, interesting. There's another solution. I'm going to try this out and we can look at the problem. So somebody shared this code in and let's see what it does when we run the tests. And then we can debug it a little bit. So all the tests come up as red, but there are no errors. What this tells me is that the code does compile correctly, but it doesn't produce the right result. So in this case, we can see on the right the result that was expected. Thanks to the person who just messaged me. Enjoy your evening. So on the right, we can see the intended result. On the left, we can see the result that was actually there, which I think to me indicates there's a problem with the logic. So let me take a look at this and let me actually expand it slightly as well, so I can just follow it a little easier. Okay. So we're taking the number of pillars down by 1, which I guess is designed to get the gaps. And then we're taking the inner pillars here, so we get those. And then I think this makes it a little easier to see. We can get rid of this. Makes it a little easier to see perhaps what the issue might be, which is that if you follow the logic here, we've got the gaps times the distance in meters, which is okay. And then we've got the inner pillars times the width of the pillar, but the width is in centimeters. And then we multiply the centimeters. So this is the order it will happen in. We multiply the width by the number of inner pillars, the width being in centimeters, then we multiply that by 100. So we get actually, I think, whatever's below millimeters, actually. So where in this logic, we're converting from the distance in meters to the distance in centimeters. Here, we're actually converting the width from centimeters to centimeters times 100, which is not the right conversion. So actually we need to multiply, I think, this by 100 and this not by 100, because this is in centimeters, which converts the distance from meters to centimeters, and the inner pillars, which are the width, which is already in centimeters, we leave that in centimeters. And so in theory, this should now pass, apart from the edge case with 0, which we still need to guard against. If there's only one pillar, then we return 0 because there's no distance. And then that gets us to the right, to all of our tests passing. So an interesting one, and also I think interesting there to observe how I dug into the code through giving different bits of it names, and then adding some brackets to clarify the order operations in the expression. That might be a useful debugging technique for you to keep in your toolkit. Okay, well, it turns out we've used the whole hour on doing a bit of programming and then me walking through this pillar solution. So I guess we're not going to get to do anything more than that. Is there anything else on anyone's mind that anyone wants to talk through? I could, if there's nothing else, maybe walk through the second one. We'll run a little bit over, but I don't mind that if you don't. But if there's anything else on anyone's mind, drop it into the chat now. Otherwise, I'll try out another one. All right, let me put the links. I'll put the link. Somebody's just asked for the links to the Codewars challenges in the chat again, so I'll put those in again. So there's 4 links there. Copy them out somewhere safe. Great. Okay, I'll try another one. And I think I'm not going to try this one. I'm not going to try this one. I'm going to try. No, I think I will try this one. I'm not going to overexert myself, because you may not have got to my favorite one, which is the cats and shelves one. If you've asked for the recording in the chat, yes, I will make sure that's sent out to you. Or by the way, there are some challenges with getting emails to you if GDPR reasons, depending on what you subscribed with. Anyway, at the end of these things, I copy out all the emails that you put in the chat throughout. So if you want to drop your email into the chat, I'll make sure that I've emailed you everything after this. Most of you should get the email anyway, but just to double check. So stick your email in the chat if you want that certain. This one with the cat in it is quite fun, so I'll leave that to you. We might start with that next week. Fun one, but I will demonstrate the logic drills one to close us off, which is you're writing code to control your town's traffic lights. You need a function to handle each change from green to yellow to red and then to green again. Complete the function that takes a string as an argument representing the current state of the lights and returns a string representing the state the lights should change to. For example, when the input is green, the output should be yellow. So let me diagram this out. If you don't know what this app is, by the way, it's called Excalidraw. It's really good. I actually shouldn't say that. My friend works on a different app called TL Draw, which I've heard is also very good. So there are other drawing apps available. But it's handy to have a little tool you can use for diagramming things out. Okay, so it goes from green to yellow to red and then to green. Green to yellow. And those need to be just one arrow. Green to yellow, yellow to red. Is that right? No, that's not right. How does it go? Green to yellow, to red, and then to green again. Is that how traffic lights work? Green, yellow, yeah, no, yellow, red, and then green. Kind of weird traffic light. I mean, that is what it says, right? I'm not getting confused here. Okay, fine. Well, kind of parallel universe traffic lights, I suppose. Yeah, great. Somebody's asked me, what's the name of the drawing app called? It's called Excalidraw, which I'll put the name in the chat. I'll just put the URL in the chat. Excalidraw.com. There you go. Yeah, so we want to go from green, yellow, red. And a way to do this, we can use ifs. So we could say, if it's green, then return yellow. If it's yellow, then return red. If it's red, then return green. So that would probably work. Need to sort of go into that one. All right, let's try that out. If current equals green, return yellow. If current equals yellow, return red. I guess else, there's no other example, so I guess it's going to be else green. And if I've understood this logic correctly, we now get all the results. I don't know why you'd even need to test other cases, but I guess we do. So, you know, the interesting thing about that, I bet I know why they've made these traffic lights weird, which is it's a tool to get you to think logically, particularly given that these traffic lights are weird and don't work as you would imagine that they do. So maybe that's why they've made them slightly odd. I got a point saying that one seemed far easier than the first one. Yeah, I think you're probably right. I think it was a little easier in the sense that it's really a kind of map from one to the other. Now, there's another way of doing this, which I'll just show off, which is you could, whenever you see going from one value to another, you can also think a dictionary. So we could implement this function as totally as a dictionary, which is we could have a, let's say traffic lights equals green to yellow, yellow to red, green to, oh wait, red to green. And then this, in theory, should get us the same result. And then we can actually extract this so we only end up creating the dictionary once, which is a bit more efficient. I think you can do this in Python. Let me find out. Yeah, you can. And then you've got to, probably even less logic here. I kind of like the solution a little bit better. Okay, I've got some questions in the chat. When do we use elif and else? Good question. Let me fold back to the previous example so I can illustrate that. And I'll put this down here and comment it out just so I've still got it. So you use if and elif essentially do a similar thing in that they both evaluate a conditional expression and they only execute the thing that goes after if that conditional expression evaluates to true. So the most simple, or rather, yeah, so that's what if and elif. I think I'm explaining that. Let me start that explanation again because that wasn't quite right. Let's take this case. In this case, we've got an if current equals to green. So in this case, we've got a conditional expression. Current is the same as green. If that evaluates to true, which is they're the same, we execute this block in here. The else is here to indicate that if the conditional expression is not true, that is, if current is not equal to green, execute this instead. So it's like a switch. If the conditional expression here is true, then we execute this. Otherwise, in the else case, we execute the other one. So that's the if and the else, but the else doesn't have any condition because it's just if this didn't evaluate to true, then do this one. It's just the opposite case. Now, sometimes you do want to have an extra case in here, and that's where elif comes in. And the behavior of if, elif, and else is another layer of complexity. So the first thing that happens is Python says, is this conditional expression true? Is current equal to green? If so, execute this one and don't execute any of the others. The if block is now done. It's complete. It doesn't evaluate this one. If, on the other hand, it's not true, it will try the elif below, which is it will compare current to yellow. And if that's the case, it will run this block. And then if none of these are true, it will execute the else. So they're kind of each in an if, elif, else. Only one of these will ever happen. You'll never have two of them happening, or all three of them. They're all kind of mutually exclusive. So the if starts it off, the elif says, well, if that didn't work, try this instead. And the else says, if none of those evaluated are true, then try this one down here. And you can actually have loads of elifs. You can have sort of, a totally different one and have a totally different result. You can only have one else though, and one if, but you can have as many elifs as you like. Thanks for the question. Another question, where is it best to learn new topics of programming, such as arrays, as some 8Q tasks involve new topics? So we do have let me actually find the link for this. Just give me one moment. One second. So we do have this intro to Python material, which is produced by me. I'll put this in I share this each time, but I'll put this in the chat. It runs you through using something called Replit, a set of exercises. You can start on this page and it will guide you through setting it up. I will say, I think it's pretty good. It's designed to kind of cater for most learners. However, I will say that I'm not so arrogant to assume that one resource will work for every single person. In fact, I think different resources often work well for different people. So if you do find that this particular way of learning is not working perfectly for you, there are a few other places. So you can check out Codecademy, which is a kind of another service you can use. Let's try that out. So these have a few things. I think they are a paid service now fully for Python. So just bear that in mind. Put this in the chat as well in case anyone would like access to it. And then there is another one called Exercism, which is also takes a slightly different approach to learning, which you can also try. They've got tracks for many different kinds of languages. You might enjoy them as well. So there are two others as well, if you don't get on with the one that we provide. I think most people, the one that we provide will work pretty well, but if you do want to try something else, you're very welcome to. And I do think different things do work better for different people, often. Okay. I had fun. I always have fun solving Codewars exercises. Thank you for your time and attention today. I'm going to circulate after this, just a final call. If you want to stick your email in the chat, I will make sure that you're on the list for the messages for the email. I'm going to circulate all the katas that I did today. I'm also going to circulate the intro to Python material in case anyone would like it, the recording, and I think there may be something else, but I'll check the chat as well. There'll be another one of these, final in this particular series next week, where we'll be tackling some slightly more advanced exercises. So look forward to that. That's all. Hope you have a wonderful evening, afternoon, or morning, wherever you are.
Just quickly, Kay, before you leave.
Sure.
You are talking about it. I don't know. I don't understand, because I've not been receiving. Can someone call me to let me know what I need to do? Because I've not been receiving email, and I don't understand the GD, how that you, that I need to sign to so that I can get all this?
No
emails?
worries. No, absolutely fine, Grace. I will send you an email tomorrow morning, and I'll ask someone to get in touch. It's
Please, thank you, because I'm missing out.
yeah.
Thank you so
Yeah.
much, appreciate it.
Thanks
I'm
for-
expecting for the solution for the one that I sent to you too.
Yes, great. I'll
Wonderful.
that's the other thing. Actually, I'm going to send out the solutions that I made as well.
Yeah. All right. Thank you.
Okay. Thanks.
Enjoy your
Have a
evening.
wonderful evening, all. And let me work out how to save the
Bye,
chat.
everyone.
See you.